Did you just raise your hand?
No, I was raising to add.
So you raised
so
your- I knew that was going to happen.
I don't think that marker works.
Don't bother.
I was so close.
It's probably about this close.
What?
Made you look.
Yeah, me too. It's so tough to put it in.
It was literally so.
Dang it.
I spiked my marker yesterday. The cap broke, so it dried up.
Spiked it. Oh, I hate what you said.
It is true.
Oh,
Every single day I my
Pardon?
so cold.
You're so cold. Isn't that a song? Yes, it is. Rolling Stones. Okay. I'm sorry, I don't. Is that what you asked? Who likes Rolling?
I said who I did.
Oh, who are the Rolling
No,
Stones?
I'm kidding.
You're kidding?
Yeah.
You know who the Rolling Stones are?
it's like who is
I
that?
know Rolling Stones.
Who is that?
They like the ones that like
Saying.
you can't. Oh.
Yeah.
Look at this girl go.
They kind of
Good job. I died.
All right, it's possible you were introduced to this concept maybe a couple of years ago. I think when I say I know of at least 3 chemistry teachers that of the current 4 that think it's a highly effective way of solving problems. Okay. And actually most textbooks that you're going to look at will use this technique. And so whenever you see things outside of this class, you're probably going to run into the same kind of stuff. So anyway, it's highly effective, very useful. We're going to use this to do a number of things. 1, convert between various units, which we're going to have to do all year. You did a little bit of this already, right? And 2, we're going to find out later that it's going to be a really good problem-solving technique from going from one thing to another. You ever heard of the word stoichiometry yet? Okay, well, that'll be one of the bigger things we do this year. So anyway, so for example, now the first couple of examples I'm going to give you are going to be really easy things, just to get us kind of get the idea of how the technique works and everything like that. And then I'll start throwing some things at you that maybe are not as easy, so we can start using it. So for example, Mr. James, could you give me a number? Thank you. That's an almost good number. And then, gosh, I don't know. I need a unit. Meters. Excellent. So let's imagine that I want to convert 17.38 meters to micrometers for some reason. How would I go about doing that? Well, it's a rhetorical question. First of all, what is the relationship between micrometers and meters? Say this again.
1 million?
1 million. Which one has the million?
The nano or micro.
Okay. So you have to be specific here. Are there a million meters in a micrometer, or are there a million micrometers in a meter? We have to be specific. You guys get that, right? Okay. But the relationship is a million. However, instead of writing out the number of million, what would be the easier way of doing that?
Scientific notation.
Which would be not a 1 times 10 to the 6. A million is a 10 to the 6. Okay. So anyway, we know this relationship. So there you go, right? Would you guys agree with that? Excellent, okay. Because these 2 things are equivalent to each other, we can make what we call a conversion factor out of that. There's 2 actual conversion factors we can make. How do we want to do this? We can say 1 times 10 to the 6th, micrometers over 1 meter, or 1 meter over 1 times 10 to the 6th micrometers. Either one of those things is perfectly valid. Which one do you use? Well, it depends on which one you need to make the conversion in question. So our conversion in question is this. So in a multiplication type idea here, which of those two conversion factors, the two possible conversion factors, would be the appropriate one to use here? Well, we want to get out of the meters and into the new unit, correct?
Yes.
And the way to do that effectively would be putting the thing that you're trying to get to in the numerator and the thing that you're trying to get out of in the denominator. So therefore, the units cancel, hence dimensional analysis. We're using the dimensions, the units, to help us analyze the problem and figure out how to solve the problem. And now it's just a matter of doing math. Hey, get your handy dandy little calculators out and have at it. You guys need to practice your scientific notation in your calculator, so you might as well go ahead and do this. You guys don't even know each other, do you? I expect me to know your names. You don't even know each other's names.
Sam.
Wait till we start doing all those labs where I start rotating. You guys work with everyone eventually. So anyway, Ryan, could you take your book bag off your table, please? Thank you.
You're out. That's Maddie.
Who's got it?
Smith.
The answer.
Oh,
Is it official?
1.738 times 10 to the
6. No, 7.
7th, I would certainly hope. What does your calculator say?
Bunch of big numbers.
Oh, okay. Yeah, all right. And anyway, I'd like to.
I got that.
Now, listen, I know, especially with the metric system, most of you are going to be, I hope, pretty comfortable with just moving the decimal point. Right? But again, remember, I said I'm starting off with things that you're very familiar with so that we learn the technique and then progressing to things that maybe you're not as familiar with. Any questions so far? Okay, let me try one that you may not be as familiar with. Can I get rid of this? Oh, let me see. Need a number. 99. Yeah. Need a, now listen, whatever you say, I'm probably going to change a little bit, so just bear with me on this. Need a unit. Excellent. All I really wanted was a quantity, so you want volume, so I want volume. So we're going to go from 9.98 fluid ounces to gallons. Without looking at the little cheat sheets that you all need to memorize. She's the only one who doesn't know that. Actually, she doesn't know. Did I tell you that? Okay. Yeah. How does one go from fluid ounces to gallons? There's more than one answer to this. Okay, I don't listen. How does one go from fluid ounces to gallons? What is a pathway that I can use to get there? Go ahead.
You can convert the pie to quart to gallons.
Could go from pints to quarts to gallons, right? How many ounces are in a pint?
60.
Ooh, look at you go. Okay, so you're saying that we can go from ounces to pints to quarts to gallons because you feel pretty comfortable with that idea. Would anyone like to offer up another opportunity? What do you
Just
got?
go straight from fluid ounces to gallons.
Do you know that?
Yeah.
What is it?
128.
Okay, good. And is that because I gave you that little sheet, or did you just know that? Or did you read your milk carton?
I think that's what we said before.
It is, okay? And I'm telling you what, right now, you guys need to like read your ingredients labels and your cereal boxes and your milk cartons, because there's all kinds of information on there. So for example, give me a second. How many liters in a gallon?
2.25.
I'm sorry, what's that?
2.25.
Now, as it turns out, this is actually somewhat of a gender-biased answer here. The young men have a much better chance of knowing this than young women will.
What was it? It was liters in a gallon?
How many liters are in a gallon?
Isn't it like 2.06 in a pint? Not a pint.
3.875.
What's that?
3.875.
Okay, that's pretty darn good.
Is it right?
Is that what I have on the sheet?
Yes.
875 or 785?
Oh, it's 3.78.
Okay. You're not a young man, are you?
No. I'm a woman. I'm a woman.
So why would I say that the young man might have a better chance of knowing this than the young women? I don't even know what that means.
Hydration.
Well, yeah, but how does that apply?
Like for sports and stuff, they say that you're supposed to drink.
Okay, so you're saying that the guys drink more than the girls?
You know, I'm saying that the guys are typically more active in
Oh,
sports that require.
yeah, not necessarily true. I was leaning some. Okay, and then after you hydrate, what has to happen? What's that? There you go. Hint, hint. You need to use the restroom? I think you need to use the restroom. I think you need to use the restroom.
Wait, this is the mix.
You're very good to use the restroom. I'm kind of not. You're about to go find out why the young men might know this better than the young women. What's that? What about them? You
Oh, it's
guys
like- it's
need to start
it's like
paying
1
it.
gallon per fill, right?
Okay, but
2 point.
Is there labels on here?
Yeah.
Yeah, there are.
This is what I'm saying. Okay, and this is where I'm going with it. You guys need to start paying attention to your surroundings, okay? Anybody have a bowl of cereal this morning? No
I
one.
did.
Put that darn cereal box in front of you and read it all.
Yeah, true.
I would just read it.
How many grams in a pound? It's on the cereal box.
Wait, really?
Yeah. How many ounces in a gallon? It's on the milk jug.
2,205.
All this stuff's on there. You guys have access. You've had access to this information for years, and you didn't even know it.
I just can't remember.
Yeah.
I don't drink
All right.
it.
Anyway, I don't know. You're not Aaron. Who are you? Josh. Josh suggested going straight from ounces to gallons because he has some knowledge. Remember I said the more of that stuff you know, the less you're going to have to do, right? Is there another thing I could do? I can think of at least one more easy one to do. If you know how many pints are in a gallon, or you could go ounces to quarts to gallons, if you know how many ounces are in a quart. You see where I'm going with that? So the more of these things you know, the less work you're going to have to do. Let's go ahead and do this one just for fun. So we have 9.98 fluid ounces. And what is the relationship between ounces and pints? Somebody already told me? 16. Yeah, 16 fluid ounces in a pint. So where am I going to put the 16 ounces? In the numerator or the denominator? On the denominator. There we go. And then 1 pint up here. Perfect. And then, according to this, going from pints to quarts, what's that relationship?
2 pints in
Yeah,
a
two.
quart.
2 pints in a quart. Where are the 2 pints going to go? Denominator. And how many quarts in a gallon? We're going to. Where are the 4 quarts going to go?
On the denominator.
In the denominator. Now, some of you guys have the billion-dollar calculators that have this whole little fraction thing and all that kind of stuff, which means you have to press like 18 different keys. You got to get the fraction in there. You got to do the parentheses or whatever you got to do. Don't touch your calculators. Do not touch the calculators. Okay?
Come on, Allison.
Others of you are just going to, I don't know what you're going to do, but I'm telling you right, here is the most efficient, and remember efficient means quick, and effective means getting the right answer, way to put this in your calculator, and all you have to do is press your division key.
I don't believe you.
If it were just this, what would you do with the 16? Divide. If it were just the quart, what would you do with your, what would you do? Divide. What would you do with the 4 if it were just that? Divide. But I'm telling you right now, so many people would do this. They put 9.98, divide by 16, times 2, times 4. Swear it would happen. I'm going to save you the embarrassment from letting that happen. So what I do, I would put in 9.98, divide by 16, divide by 2, divide by 4. If it's in the denominator, you divide. If it's in the numerator, you multiply. Boom, done. Try it, see if you get it. What'd you get?
0.0779.
0 point what?
0.77.
0
779.
779
69.
69. Is that all? 6875. Blah, 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 blah. Okay. That might be right. Anyone get that?
I did.
Something like that? Does that make sense?
It does.
Does the answer make sense? You should always see if your answer makes sense. You get that, right? Because we all hit stupid things in our calculators once in a while, right? It's always a good idea to see if it makes sense before we do anything else. We're basically taking about 10 and dividing by about 10-ish. Or actually, no, 100, sorry about that. Taking 10 divided by close to almost 100. So does that make sense? Sure. Okay. Now, here's the problem. How many significant figures? 3. What are we going to do with these things? And the ones. What's that?
Nothing, because you just count.
Oh, okay, good. Those are exact numbers because how many fluid ounces in a pint? 16. It's not measured. That's an exact number, right? So we do not include, and I'm just going to make this general rule of thumb, we're not going to use conversion factors for determining our significant figures. So the only measurement that was made was that one, 3 significant figures, all multiplication and division. So our answer should only have 3 significant figures. So this is going to be stated as 0.0780. Excellent. Look at you go. And that's gallons because all those units cancel out. Good job. So now we've done a conversion where we had the numbers that we were using were in the numerator. Now we've had an example of multiple steps, and all the numbers are in the denominator. So this would be the correct answer on a quiz test or some whatever we got. Just for fun, let's convert our ounces to gallons directly and see what happens. Theoretically, we should get the same answer. I don't know if anyone's tried it yet or not.
I did. I don't believe you.
Yeah, you should. I lied.
I know.
What can I say? It's not in salad.
Did you do it already?
You get the same
Yeah.
thing.
Did you get exactly the same thing?
Pretty
Okay,
much
I
exactly
will
the same.
say this, and if you guys notice in that little half sheet of paper that I gave you, many of the conversions go out. They might have 3 or possibly even 4 significant figures in it. What was the quart to gallon, or the quart to, sorry about that, the liter to gallon thing, 3.785? Okay, the reason I'm giving you all that is because that way it's going to give us a better chance of getting the same numbers no matter which way you get there. Anyway, so we get the same answer here. So that's the whole point of having these equivalents, so that you do get the same answer. Any questions so far? Have you done this before? It's possible some of you have been introduced to this before. Just out of curiosity, how many practice assignments did you have on that? Just 1 or 2?
We were like 3 days into
3 days
it.
into it? Okay. So she's going to be, if you have any questions, Abby, right? Ask me.
No.
Do this. I don't care. Okay.
Now you might be wondering why the non-honors chemistry class is ahead of the honors class. I'll demonstrate. What's this? Shh. Oh,
Why are you asking me? I don't know.
why not?
No.
Right. Do you see where I'm going with that?
I'm trying. We know what that is.
He's not doing that till later. I did it early so we can start doing things. Anyway, it's okay.
Oh.
We haven't covered
I
it.
see what you did there.
See, yeah, thank you. Okay. Well, then, let's try this. Need a number.
Try this. Me?
Yeah.
78. I didn't know we did that. Because that's gonna suck. Haha. Don't bother. Oh my.
Now what? Okay, first of all, what's the issue here? What's the first issue that you might recognize?
There's 2 different US.
What's that?
2 different systems, I guess.
There are 2 different systems, but we haven't done that yet. So 2 different systems that we're dealing with here. What else is different?
They're different.
There's multiple units involved in the value. Would you correct?
Not like
And we're going to have to convert both of those multiple units. This ought to be fun. So when you run into a scenario like this, don't get your pennies in a bunch and panic, okay? What I would suggest doing is picking one of the units, whichever one, it doesn't matter which one you start with, convert that one first, and then worry about the other one. So, which one do you want to go for first? You want to convert grams to pounds, or you want to convert milliliters to gallons? It doesn't matter. Milliliters to gallons, he says, because he wants to be different, right? Okay, so here we go. So, would anyone like to offer up a suggestion as to how to go from milliliters to gallons? There is way more than one way to do this. Anyone throw something out? Hey, I would highly recommend not looking at your sheets. You're supposed to know these. Go.
like milliliters to liters.
Would anyone concur? Milliliters to liters?
I would.
All right, here we go. So, how can I go from milliliters to liters? What's the relationship?
1,000.
It is 1,000. 1,000 what?
Milliliters.
Milliliters in a liter. So where am I going to put my 1,000 milliliters? Anyone can shout this out. In a numerator, because we want the milliliters to cancel out, correct?
Yes, we do.
So 1,000 milliliters, 1 liter, and our milliliters be gone. Now, as it turns out, Mandy here knows what to do next. Now we need to go from liters to gallons.
We need to multiply by 3.785 on the top numerator.
3.785 what?
Liters.
And down in the denominator,
1 gallon.
1 gallon. I picked on Mandy because she's the one that threw that out there about 10 minutes ago, right? Now my liters are gone. I'm in gallons. I'm halfway done with the problem. Now all I need to do is go from grams to pounds. There's a number of different ways to do that. Anyone want to throw one out there? Go ahead.
Grams to kilograms.
Okay, there's a way. So what's that relationship?
2.205. Right? Oh, kilograms in a pound.
1,000.
Oh wait, is that it?
It's
Or pounds in a kilogram? Wait, yeah, pounds in a kilogram.
So where am I going to put my pounds?
No,
Or sorry about that. Where am I going to put my?
the
What are you doing?
It's
We're
grams to
going
kilograms,
directly-
Josh.
We're going from what grams to
Oh yeah, grams to kilograms.
kilograms. Okay, so what's going to go where?
The kilogram. Well, the grams are 1,000 grams are going to go on top. Or
Yes.
yeah,
Yes.
Everyone concur? 1,000 grams go in the numerator.
it's a,
Denominator.
okay. That was
That's hey.
Come on,
Listen,
John.
listen. You were farther along than many. You just got confused. And then of course 1 kilogram up here.
just a million dollars.
And do we know a relationship between kilograms and pounds? 28 point what?
35.
35 what?
28.35 kilograms in a pound.
No, that's interesting.
Is it not 2.205?
It is 2.205 pounds
In a
in
kilogram.
a kilogram. So what's going to go in the numerator? The pounds are going to go in the numerator. And now we can see that we are left with the unit of pounds per gallon, which is what we were going for. So do you guys see what I did where I just broke it down into 2 separate things? But you can combine them all in one shot. So on your handy dandy calculators, see what you come up with. I'm curious. And then I'll tell you how I would do it. One of the many ways that I would do it. So, I told them, when was it I gave it? I gave it to them a while ago. I'm assuming you know the metric system. I'm assuming you know the US system. The more you know the metric system, the more that you know the US system, the fewer of these you need to know. But you will not have access to any of these things unless it's physical tests. Okay? We're going to work on this for nearly a week. So you've got time. Plus you've already had a couple days experience, right? And then on the metric system, what I focus on, micro through kilo, I think, for the most part. Is that what I told you guys?
Yeah.
Or nano through kilo, right? I went nano through kilo. All right, just out of curiosity, Peyton, what'd you get? It's okay. There's a lot of you that are confused. You didn't get anything?
The canceling of the units.
Oh, you're confused with the, I don't care about the units right now. Did you do the math yet? Okay. Did you do the math yet?
Yeah.
What'd you get? Okay, did anyone get anything different than that? What'd you get?
65.432.
No, it's just, what, did you get anything different than these? You got, anyone get any different than these 2? What'd you have?
65.51.
Okay, oh, okay. So here's what's interesting. We have all these young students here that are in pre-calculus or above doing simple multiplication and division and come up with 3 different answers. That's kind of interesting, isn't it?
Yeah, it is.
Yes.
I don't know which one's right, because clearly I make up nearly every problem that ever gets done. So, but let's do this. Here's how I would have done it. There's multiple ways to do it. Here's how I would have done it. I would have taken this, times this, divide by that, times that. That's the way I would have done it. Just done. Boom, 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 boom.
Could you just cancel the thousands and multiply them?
Yeah, or, okay, whatever. I'm just saying, if you want to know. Or you can just cancel these thousands out. So, this times that. Either way.
This plus this.
And I know that you're still confused about the canceling of the units. You're not the only one. There's 8 other people. So when you do it that way, which is the answer that's actually correct? 65.432. However, since our only measurement in here is this one, my answer is limited to 3 significant figures. So the correct answer would be 65.4 pounds per gallon. That's a pretty dense stuff.
Loves per gallon.
Oh, you want the symbol for pounds? No, it's pound or number, unless you're 14 years old.
I'm 12.
Or, yeah,
Or Josh.
whatever you guys are. I've used that before. So it says, oh, hashtag 17. What? All right. Any questions? Would you? I think you need to try one on your own. Would you agree? Yeah. Let me give you one on your own. 2, actually. I'm
What
going
are
to
we
do 2.
gonna do?
You can do what? Yes, because you're going to have partners on quizzes and tests.
Is that true?
That is not true.
Josh.
Actually, I believe possibly 1
Also is true.
test.
It is true.
Maybe. Oh no, that's for AP. Forget it.
That's not true.
Not you guys. Not you guys. Da, 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 da. Akira. Yes. I need a number.
61.4.
Ooh, look. See, she's getting pretty good at this. 61.4.
No fractions.
Can't remember.
Point
It's not Caleb. It is Caleb? Okay. I need a quantity to be measured.
Pounds per square inch.
Excellent.
What did you say?
I need a unit of length.
Pounds per square meter.
Did she just say meters? Oh, she did say
Centimeters.
I need a quantity.
centimeters. Gosh.
I need a number. And I need a unit.
Milligrams.
Who?
Milligrams?
Okay.
No, it doesn't exist.
It does. Tons.
Stones.
Ready, set, go.
The slugs.
Top one's a little harder, I think, but that's you guys decide. And there's like 14 different ways to get there. I might be exaggerating a little bit. There's only 13. So I can guarantee that every single guy in here, next time they use a urinal, is going to look on there and find out what I'm talking about, huh?
I know what you're talking about. I just can't remember the name.
Actually, it's on the girls too, except they usually aren't backwards. So. So you see, Abby, the difference between Mr. Hogan and I is he subtly makes fun of people. I just call him out. Your turn's coming. How's Florida? How's Florida? How's Florida? You were somewhere nice. See, perfect example. And I know it's early, you guys haven't had the opportunity to use a lot of the conversions yet and everything. However, my suggestion to you is to wean yourself off of those sheets as soon as possible. And I say wean yourself off the sheets and 15 people pull out their sheets. Okay. Some of you have started. I can tell some of you have started the process. But it's hard to memorize random things that you really have no idea what you're using them for. Now you know what you're going to use them for.
Wait, that's not right.
Hi, how are you guys doing? Have you consulted with a colleague? Colleagues don't know either.
Hey, yeah, I'm done, bro. I think,
Was that
brother.
the console?
Yeah, let's consult.
I think I got it wrong. What'd you get? That's
You got 9,000. 61.4 centimeters is equal to 9,000 miles.
I'm sure it's backwards.
Okay, what do you think?
I got 1.
Good.
Yeah.
Yeah, that's about it.
Except I need to memorize it. I was
What
like,
is it to negative?
I was like,
I'm doing it backwards. That's what I'm doing.
Hey, man, what are you doing?
So you can sort of like,
Wait.
I think I got them both very wrong.
Yeah.
I know the units backwards.
you can.
We just get
I
same
know
thing,
what
just
I
get-
like to do. My rule of thumb is anything over 10 to the third or 10 to the negative third, I put it in scientific notation because I have to write less. I'm lazy.
Oh, well, times.
All right.
10 to the
I
negative
don't know. What time we get out
Now I don't know.
here? I don't know. What time we get out of here?
5.
5? About now.
I should have done something wrong though, because I didn't know the meters to miles conversion. But I do know the centimeters.
Why didn't you just do millimeters or centimeters to miles?
It depends. There's like seriously. I was kidding, but I wasn't kidding that much.
Well, that's
But
what
there's
I
like
did.
12 different ways to go on this.
What's the numerator?
Depends what you know.
Let's check this out. 1 meter.
It's 10,000 centimeters in a kilometer.
Oh, you're gonna remember that?
Well, it's pretty easy
Okay.
because
Okay.
centimeters to meters.
Okay.
It's 100.
And again, different people have different comfort levels.
100,000.
Correct. Just out of curiosity, anybody get an answer for the first one? We're not going to go through and walk through it today, but I'm just curious to see what answers we got. What do we get for this one?
3.82.
Say this again.
3.82 times 10 to the negative 4.
Does anyone concur? Does anyone vehemently disagree? Or just even slightly disagree? What do you have?
I got a different answer. What? No, I got
Then round it to correct number significant digits.
6.
I think it's wrong.
Short. No.
Eight. Say this again.
1.10
Times 10 to the 8.
You got the other one?
What you get?
I got 0.000003.
Okay. Actually, so far,
It's close to that first one, I think.
yeah, closer to that one.
I got the units from my teachers today. So.
Yeah, I got nothing. I have nothing. I haven't graded any of your stuff yet, so what do you want me to write?
Yeah, at least just right here.
He's nice.
An effort grade. Yes.
Effort grade. I don't know. Have you tried?
Yes.
Do you want to be